Okay, so we're talking about interval notation and set notation. A collection of objects is called a set. All right, so if you have a set of numbers, you could have a set of numbers that was like 1, 2, 3, 4, and then a comma, and then ellipses, right, which is the 3 dots that say this continues on, right, ellipses. So you can use braces to represent a set by listing its members or by using set builder notation to define the set in terms of all the properties of its members. So this is set builder notation. It always has the braces on the ends and the X and this line right here. And this is red. The set of all real numbers X such that X is a whole number and X is odd. So this is just the terms of the members in this set. Okay, they are whole numbers and they're odd, so odd whole numbers. Okay, if the members of set A are also members of set B, then A is a subset of set B. So if you look at this, if set A is A and B, and set B is A, B, C, D, then A, B is also in this one, correct? So therefore, A is a subset of set B. It's a lot of words, set, okay? So when we talk about natural numbers, those are all of like your counting numbers, 1, 2, 3, 4, 5, 6, and up. Whole numbers are all of those numbers plus 0. Integers are all of those numbers plus the negative numbers. And then rational numbers are numbers you can put as a fraction, okay? Irrational numbers have go on forever, don't have a stopping point, like pi, keeps going on. And real numbers include all of those, and then these are their symbols. So when we have to define those later, you'll want to reference this table if you can't remember the fancy letters. All right, so bounded intervals. All right, bounded intervals mean that there are boundaries, okay? So this should be something that is familiar, open and closed circles, right? And this might be a little bit new. All right, so if we have this inequality, that means that our numbers are all between A and B. All right, so if you have A here and you have B here, we are shaded in between because all of our numbers are between those, right? Well, where A is located, whatever that number is, there is an equal to bar. So that means that A should be a shaded in circle. If I look on side B, wherever B is at, that should also be a shaded in circle. And then I should be coloring in between because all of my numbers lie between those two numbers. Okay? A equal to bar is equivalent to a bracket. All right? And no equal to bar is equivalent to a parenthesis. So brackets mean that those numbers are included, and parentheses mean that they are not. So if you have a closed circle, that should go along with a bracket and an equal to bar. So the only difference between this first one and the second one is that we don't have the equal to bars, so therefore we should have open circles on the ends, and if we write in interval notation, we should have parentheses. All right, on this one, if you look at it, you have an equal to bar on the A side, so A should be shaded in, but you don't have the equal to bar on the B side, so B should be open. Same thing with your interval notation. On the A side, you should have a bracket. On the B side, you should have a parenthesis, and then this one is just the exact opposite of that, okay? So when you talk about unbounded intervals, that means that you either start somewhere and continue to the right, or you come from the left and you stop somewhere, okay? So if all of your numbers are greater than or equal to whatever this number is, okay? Let's just say that's 3, all right? This is 3. So all of my numbers are greater than or equal to 3. So that means I'm going to start at 3 with a closed circle, and I'm going to shade everything that's greater than 3. So that means I would start at 3, it's equal to, and then I would go all the way to infinity, okay? Infinity always has a parenthesis every single time. If you look at all these, they're all parentheses if you need to make notes of that. All right? So if I say x is greater than a, then that just means I don't have the equal to bar, so I should have an open circle on a and a parenthesis with my a. If all my numbers are less than or equal to, we'll just say that this is 3. Okay? That means I need to be shaded all the way to the left-hand side. Since there's an equal to, I will have the closed circle. And if I write it in interval notation, that would be a bracket. And you always go smallest to biggest. It's always smallest to biggest in interval notation. So you wouldn't say like 3 comma negative infinity because 3 is bigger than that. We read left to right. Okay? If it's less than with no equal to, again, you would have your open circle and your parenthesis. Okay? And if you're shading the entire line, that's just negative infinity all the way to positive infinity. All right. Let me zoom out. So we are going to write all of these, all 4 of these problems, in interval notation. That means we have a parenthesis or the bracket and then the 2 numbers in the middle with the comma. So what I like to do is I like to say, okay, this is bounded because I'm between 2 things. So I'm going to start with -2, and I'm going to go all the way to 3. So I just have -2, comma 3. So to figure out if I need my brackets or parentheses, I look on the side with the -2. There is an equal to, so I should have a bracket. And on the side with the 3, there is an equal to, so I should have a bracket. So this is interval notation for whatever this is right here. Okay? Notice on this one, I only have one number, which means this is going to be unbounded. I'm either going to be shading to the right or to the left, right? So if I think about that, x is greater than 1. X is greater than 1. So that means that 1 is the smallest number that I have. So I'm going to start with 1, and then things that are greater than that would go all the way to infinity. I don't have an equal to, so I'm going to put a parenthesis with the 1, and then infinities always have a parenthesis. All right, so if we look at this one, this is bounded, right? I'm shaded between 2 things. So I start at -3, and I go all the way to 4. I look at -3, it's shaded in, so that means I need a bracket. I look at 4, it's an open circle, so I need a parenthesis. So on part D, this is unbounded, right? So I know that I'm starting somewhere and I'm stopping here. So since this is going all the way to the left, that would be negative infinity with a parenthesis, comma, 3 is where I stop, and 3 has a shaded in circle, so I would put a bracket. So moving on to set builder notation. I always have the braces on the ends, the x and the such that. Okay, this part right here is always the same. So if I had a graph, all right, this is an or statement. See how I have an x in this statement and an x in this statement? That shows me right there that I'm going 2 different directions, okay? Because in this set, x is less than or equal to a. So I would go to a and put the closed circle, and I am less than that. Or x can be greater than b. So I would go to wherever b is, open circle, shade to the right. Okay? When it's everything except one number, then you would say that x is not equal to that one number, but it's everything else, right? So that's how we would state that, okay? So we're going to sketch the graph of each set of numbers. And this really should be written like, well, that was a really bad bracket. A brace, an X, a such that, and then this stuff. Okay, that would be in set builder notation. So we're supposed to sketch the graph. So go ahead and get you a number line on here. You need a number line on both. All right, so since I've got right here, I see that x is in between 2 and 5. Those are my end points. So I'm going to go to 2, and I look at this symbol right here, and I see that there is no equal to bar. So on 2, I should have an open circle. All right? Then I know that I'm going to go all the way to 5. I look at 5 right here, and I see that I have an equal to bar on that inequality symbol. So I'm going to put a closed circle at 5. And then since x is between those, I'm going to shade in between them. And you want to make sure that your lines for shading are dark enough so that we can see them. All right? And then we're done. Okay, so if we look at this one, this is an OR. When you have an OR, you're usually going opposite directions. Okay? So if I look at this, I see that I'm going to go all the way from negative infinity, and then I'm going to stop at -1. And since there is a parenthesis there, I know that it's going to be open. So I draw all the way from negative infinity. Make sure I put an arrow on the end to signify that keeps going. And then I shade all the way to -1. Okay, so that's one half of this statement. Then it says, or I can start at -1, notice, open circle, and go all the way to positive infinity. Now, just because, let's write this a different way. Instead of saying like this, I could have written it as all x values such that x cannot be that one number, and that one number is -1. All right, so now we're going to write set builder notation for what they're giving us. And we've already done this one. We just did it on that last problem. So I'm going to put a different one here. I'm going to go ahead and write this down. -infinity to -2, or 5, infinity. All right, so if we're going to write set builder notation for this, this says x is greater than 5 and x is an integer. You have two pieces, right? You have this first piece of info and this second piece of info. So you're going to have two statements inside. So you always have your brace and an x and such that. And then mathematically, I have to write x is greater than 5. So that would be x is greater than 5. And then I'm going to put a little semicolon here. And then I have to show that x is an integer. That's where the symbols come in. So the symbol for integer is a z, and then you're going to put like an extra diagonal right there. So it kind of looks like a funky z. All right? So you're going to say x, and then you're going to learn a new symbol here. It's like a curved E. So you draw a C and then make it into an E. This means exists in. So this is like saying x is an integer. So x exists in, and then you put the symbol for integer. And then you close it up. So you've made both of your statements inside set builder notation. All right? So now I have two statements, but both of them can be written mathematically. So I have my brace, the x, and the such that. Now if I look at this, all these numbers, I'm going to come from the left and I'm going to stop at -2. So I know that x is something in reference to -2. So I have to decide if all of these values are greater than -2 or less than -2. So if you think about it, if I come this way and I stop at -2, all of these numbers are less than, since I have the bracket, or equal to -2. Or then I've got x is something to 5. So x and 5, leave you a little space. So if I started at 5, open circle, right, and I graphed to infinity, all of those numbers would be greater than 5. And then that's the only info I have, so then I close up my brace, and I'm done with that statement. All right, the set of all integers less than 3. So first they told you that these are all integers and that they are less than 3. So you have two pieces of info. So get your brace, your x, and your such that. So you know that your numbers are less than 3. So x is less than 3. Put your semicolon. And then it says it's an integer. So you would say x exists in, and then the symbol for integers is a z with the extra diagonal. That's the only thing that you have to state. So close, and then you're done.